Hello everybody and welcome back. This is my newest project. This is a CO2 dice. Welcome back. This is a CO2 dice. It is a very simple CO2 monitor for the air in a room, and it displays the amount of CO2 in parts per million through the simple interface of a dice. Like right now, when it was blinking, the level of CO2 is higher than it should be. Namely, it's higher than 1000 parts per million. The CO2 dice is a monitor with a very simple user interface. The amount of CO2 in the air is proportional to the number of dots on the dice. Once it starts blinking, it's time to open the windows and let some fresh air in. It's that simple. The hardware design is simple too. The whole setup just consists of one microcontroller and one sensor. The microcontroller is the WeMOS D1 Mini, the sensor is the Sensorion SCD30. The PCB is open source and available online or to buy through EasyEDA and JLC PCB. It is very easy to put together because it only needs a set of standoffs and very few solder connections. There's literally nothing that can go wrong putting it together. The software for the CO2 dice is open source too. It is available through GitHub and it's licensed under GPL v3. The GitHub repository points to the repository on EasyEDA. The repository on EasyEDA points to the software on GitHub. They're licensed both under GPL v3 and they're free for commercial use. They're free for reproduction. They're free for modification. I will be maintaining the base code, and everybody is just free to do what he wants. The files that I provide are the source files for the PCB, the layout, files for making a desk stand or a wall mount, and everything else you need to get going is the Arduino IDE, a few libraries, and a computer to put the software on the microcontroller. Even though the design is pretty minimal, you still have a few choices you can make. You can either use it as a development board by using standoffs and connectors mounted to the top side of the board. You can make a board where the microcontroller and the sensor is located under the board for a more pleasing design. You have the possibility to connect all the remaining data lines from the microcontroller to an expansion board and make use of those in any way you like. And you can, if you need, connect a power source through a barrel jack adapter or use the USB plug to deliver power. Also, the wall mount is designed so you can mount the microcontroller one way or the other. Everything is very simple, very modular, and basically up to whomever wants to build it. So why are CO2 monitors so interesting all of a sudden? Well, there is the theory that the concentration of CO2 in a room, like for example a classroom, is proportional to the spread of the coronavirus in the air. Because when we exhale CO2, we exhale a certain amount. The amount is an indicator for the amount of times that the air has passed through a lung. And if you have somebody with coronavirus in that same room, he will be breathing into that too. So the chance of the spread of coronavirus is proportional to the amount of CO2 in that air. So if you have an indicator that tells you when the CO2 level has risen beyond a certain threshold, and it tells you to open the windows, and you do that, you not only get better air, but you also let out all of the contaminated air. The theory is pretty sound, and this is a very nice way to achieve that. Now, the implementation is very simple too. Basically, there's just the microcontroller connected to the Sensorion over I2C, and all of the LEDs are a single string of WS2812Es. And that leaves a lot of pins free for expansion later on. Also, all the parts are chosen so you can have the bare boards assembled through JLC PCB. So you can actually order a fully populated board with all the LEDs, all the resistors, and everything you need already on it. The price per board is below $2, which I think is pretty good. My first setup was just this development board with the microcontroller and the sensor and a plain strip of LEDs. And if you want to, you can go that route and not use the board at all. The setup remains exactly the same, and it works exactly the same. As for the pricing of the whole set, I tried to stay within the vicinity of 50 euros. So the microcontroller is about 4 euros. The sensor is about 40 euros, and I did try others, but this one just came out best. A board is around 2 euros plus shipping, and parts for a wall mount or a desk stand are around 1 euro. So I'm right in that ballpark. If you choose to use a power supply plug, that needs to be added as well. So that might be the point where you get above 50 euros. But that was the price range which I wanted to set, because most of the other kits that contain air quality sensors or CO2 sensors, they're all in the vicinity of about 100 euros. And most of them don't come either with a case or a wall mount, and they do not provide a dedicated power support apart from the programming port, which maybe you don't want to use. So that was my choice for the parts that I had. I wanted to have it modular. I wanted to have it in a way that you can use it for experimentation and build on it. I wanted to have it expandable, so you could, for example, use the Wi-Fi chip on the WeMOS to communicate the CO2 measurements through ThingSpeak, for example, to a web server, and have control over the rooms that you have these in. So it's a very nice way of keeping track of things. It is a very simple interface. It just tells you the amount of CO2 in the air. Each dot is 200 ppm. If it starts blinking, you're at or above 1000 ppm, and you should open the windows. If it starts blinking harder with all the LEDs or 6 LEDs, then you should maybe open the window a little bit longer. And I really like the idea of the thing, because right now it helps us to identify problems that we have with the air that we're spreading inside of a room. It might help with corona infections by just giving us an idea of when it's time to air out a room. And even if that doesn't work, if we put this into a school and kids don't have a headache after school from being exposed to too much CO2, well, then it's good too. So that's my newest little project. Thank you very much for watching, and bye bye.